welcome everyone. Thank you for coming. This is the Earth Engine plus Cloud Theory session. Hopefully we'll get a few more stragglers in. I'm Brady Alred. I am here all week. I'm a cloud geographer with Google. I'm here all week. If you would like to talk to me about this, about Earth Engine, about science, about change detection, about vegetation, frameworks, you name it, I'd be happy to visit with you. I love Earth Engine. I love using Earth Engine to solve problems. And I really like this type of stuff in terms of using integrating Earth Engine with other tools to make things more operational and to really make a greater impact. My colleague Sean is in the back. Wave your hand, Sean. He's going to be the TA for the session. There are going to be some things that you can follow along with. You don't have to if you don't want to. And I'm going to show a few things that you won't be able to follow along with, but a few you will. And so feel free to do so. If you run into any troubles, just raise your hand, and Sean will come and help. And if we can't help in the moment, stick around and we'll solve the problem afterwards. So a quick pop quiz. We are in the discovery room. Which number is discovery in the space shuttle series? Anyone know? How many space shuttles were there? Just shout it out. 7, 4. I think it was 5. Someone can check me on that. I think it was 5. And Discovery was number, boy, we're not very lively. I'm trying to get the room going. Discovery was number 3, I believe. Someone can double check me on that. Discovery was number 3. We have Atlantis, Discovery, Endeavour, Columbia, Challenger. I think those were the 5, and I believe we don't have any Challenger or Columbia rooms in this building, unfortunately. Okay, so with that, we're going to get started. So we're going to talk about Earth Engine and GCP, Google Cloud Platform, and this is really an introduction talk to introduce you to the world of GCP. Earth Engine has a long history, right? Earth Engine was actually started before GCP was really even a thing. And people have been using Earth Engine for a long time. And some of you may or may not be familiar with what GCP, Google Cloud Platform, offers. And so you can view this as an introduction. And in reality, I'm actually going to be touching on a lot of different things. And I can direct you to, go to this session tomorrow to learn more about this. Or go to this session on Wednesday to learn more about that. And so just view this as a kind of a peek behind the curtain and then an opportunity to learn more. Okay, Google Cloud, as I said, it's our cloud platform for lots of different services. We offer lots of different products, right? The first question you might be asking yourself is why? Why Earth Engine and Google Cloud? Why are we bringing these two together? Google Cloud's goal, you could say, is really the same thing. It's the same type of goal that Earth Engine has. Google Cloud's goal is to say, hey, let us do most of the work so you can focus on your question. You can focus on building your solution. You can focus on X, Y, and Z. There was a time and a place where many of us as geo-nerds, if we're going to call ourselves that, we're very interested in these things right here, right? Building all of these things ourselves. We started doing that because we had to. No one was going to build them for us. But the world has changed, right? And now with Google Cloud, Google manages all of these things for us, and we can just focus on the things that we want to focus on. So the story is very similar to Earth Engine, right? It's the same type of story. With Earth Engine, it's let us manage the data. Let us manage the compute. You, as a user of Earth Engine, gets to focus on the question. And so a few years ago, it became there was this natural fit, all right? Earth Engine belongs in Google Cloud. So that's what happened a few years ago. We started making this transition and moving Earth Engine into Google Cloud, and it is now a Google Cloud product. The thing about Google Cloud is we offer lots of different services and different products in Google Cloud. Now, the one thing I'm going to highlight here, right? Many of the services in Google Cloud are paid for services. Earth Engine, depending on what you are using Earth Engine for, can either be a paid for service or a non-commercial service. In Google Cloud, many of these products that we're going to discuss today, and in general, many of them have free tiers. So there'll be an opportunity for you to just get started and get moving with these products and these services and to explore them. But just buyer beware, there is a cost with running many of these services, something you may or may not have with Earth Engine. Okay. So we can divide. For today's talk, we're going to divide this into two categories, really. We're going to talk about services that we provide in Google Cloud and that Earth Engine can integrate with. And then at the latter half, I'm going to talk about management tools. And for most of these, all of these except for, well, two of them over here and then the two over here, I'm actually going to go through and show you how to use them. And so you can get a sense, you can get a flavor of how to interact with Google Cloud with the Cloud Console and what that means. OK, so we're going to start with one that is a little bit close to home for me. I live in western Montana, which in some regards can be considered the fire capital of the United States. All right, there's a lot of fire activity, not just actual fire, but a lot of research about fire going on, a lot of fire agencies in western Montana. On Wednesday, July 26, at 9:15, my 15-year-old daughter says, "Hey, Dad, look at this." And we look out the front window. This is looking out the front window. That's my neighbors across the street. That's a smoke plume going up in the hills away from our house a little bit. So we sat there and we looked at it for a while. It got bigger. My son took a picture, and that's what it is. At 9:30, my daughter says, "Hey, don't you work for Google? Can't you figure out where this fire is? Don't you guys have some satellites or something that you can do?" And I thought, oh my gosh, this is a perfect opportunity, as a father, to teach my children, hey, this is what Dad does all day sitting in front of this computer. And so we did that. I'm going to click on this link. You can follow along on this presentation if you want. It's on the agenda on the website. So I'm going to click this link, and I made a quick little Earth Engine script that I adapted from something that was online that looked at the GOES data for that particular day. And I was able to say, this is the fire right here. This was, I believe it was the Big Spring Fire, if I remember correctly, around that time. So it was just east of Arlee, Montana. And this was the fire. So we were able to detect where it was. And I was able to show my children, hey, that's where that fire is. We're not in danger. We're going to be OK. We have some friends that have some property over there. I actually called them that night and asked them, hey, are you guys all right? And they said, yeah, we're fine. There's no worry. But then going back to the slides here, going to bed that night, I thought, wouldn't it be nice to have a fire alert system that sent me a text message, sent me an email, did something to warn me that there's a fire coming up, all right? So by 9 o'clock the next morning, I integrated that script into Google Cloud using Cloud Functions, Cloud Scheduler, Cloud Pub Sub, and Cloud Logging to create this fire alerting system. And this is just to give you an example of the tools that I used in Google Cloud. So Cloud Scheduler kicked off every 15 minutes. It ran an Earth Engine script. It used PubSub to invoke a Cloud function that actually kicked off that Earth Engine script. And then using logging, if you were at Geo for Good last year, you'll recognize this was Michael DeWitt's session that he taught. Using logging and monitoring, it was able to send me an email if, in this case, detected increased number of fire pixels provided for us. And lo and behold, that night around, I think it was 8:45 or 8:45 the next day, I got an email. Here it is over here showing, hey, Missoula fire alert, log alert fired. A little text message I wrote myself. There is fire activity near Missoula, and it included a link to click on that I can go say, oh, that's where the fire is. If you want to learn more about this, Michael DeWitt is actually going to expand this concept and actually build a real fire alerting system that could be applied to any other type of, it doesn't have to be just fires, any other type of alerting. That's going to be taught tomorrow afternoon. I'll be in that session helping them, so come and check it out. But these are the types of things that you can do with Earth Engine and Google Cloud, right? We're not writing academic papers anymore. We're making things operational. We're making things real. We're putting the pieces together to really do all the things that we've talked about for years, maybe even decades in the remote sensing community. We're putting them all together to actually pull it off now. Okay, so I'm going to show you a little bit here. With Google Cloud, we have what we call serverless compute. And one of those components of serverless compute is cloud functions. And these are just little microservices that you can wire up to run Earth Engine scripts for you, essentially. So I'm going to show you an example. One of the things that people like to do a lot of the time with Earth Engine is to build an endpoint where you can send information to an endpoint and get information back. And so using this simple architecture here, we're going to send information to a cloud function, and it's going to compute stuff in Earth Engine, and it's going to send it back to the user. So I'm going to open up the Google Cloud Shell. You can open it up if you want, shell.cloud.google.com. You're not going to be able to follow along on this one because everything was pre-built, essentially. But the Google Cloud Shell is essentially a very small virtual machine that allows you it gives you access into Google Cloud, and it allows you to build small things, deploy cloud functions, and interact with other Google Cloud services. And here I have this thing here called NDVI endpoint. And once I click it, we're working in the Cloud Shell editor, which allows you to actually edit a bunch of files and different things. This right here is an Earth Engine script that I actually wrote in the code editor, and I copied it here. All it does is calculate NDVI given a time period, a start date, and an end date. Make it larger. OK. Is that better? There we go. Thank you. So this calculates NDVI. It's just a simple script I wrote in the code editor using Sentinel-2 surface reflectance and given a start date, an end date, and a region of interest. And what I did is I was able to deploy this script into Cloud Functions and create an endpoint. And what I'm going to show you here is I can just send the script was set up so it accepts a GeoJSON, a very common geospatial format of a polygon in this case. Here's our GeoJSON defining our polygon. Down here is the properties of the GeoJSON showing the start date and the end date. What I did is I deployed this script into Cloud Functions, and I can just send a post request that contains that GeoJSON to this Cloud Function, and it's going to calculate NDVI for me and return the result. There it is, right there. So this specific polygon on this specific time period had an NDVI of 0.5. I can go in here, and I can change this date, let's say to 2020. It's going to save this automatically for me in my GeoJSON. I can rerun this query, and it's going to give me a different NDVI. And so this is an example where you can create an endpoint or a microservice where you can just send information to your Cloud Function. It will process it, calculate what it needs to calculate in Earth Engine, and send it back to the user. So if you're in the business of making applications, if you're in the business of moving information from one place to another, your mind should be immediately churning and say, hey, I could use something like this. You could put this endpoint behind an API gateway, or some other type of wall to protect it. You can provide keys for it, so it's not just open. This particular case, it's open right now. But you can use this to glue many pieces together and to be able to get information out of Earth Engine and downstream into some other application. Okay. I'm going to go back to the slides now. So this is an example of using our serverless compute in Google Cloud. Again, there's a session on the agenda called Architecture Potluck, where people are going to be sharing different architectures with Earth Engine and Google Cloud. If you want to learn more about this, I invite you to attend that session as well. Okay. Within Earth Engine, we have the ability to also interact with cloud storage. So cloud storage is Google's blob store, where you can store different types of information. So within Earth Engine, you can export images to cloud storage. So if you've computed an image, let's say an NDVI mosaic for a particular area, you can export that to cloud storage as a GeoTIFF or as a TF record file format. You can also, you maybe have been familiar exporting to Drive. You can do that as well, but cloud storage is where you can export within Google Cloud. You can also export map tiles. And so once you create an image in Earth Engine, you can create map tiles to be able to overlay on top of a base map or a Google Maps-like interface. And you can write those tiles to Google Cloud as well. Cloud storage. So here I have the list of things that you can export to Google Cloud. Videos, you can export tables as CSVs, GeoJSONs, KML, shape files, and so on and so forth. You can also read stuff from Google Cloud as well. So who here has ingested an image into Earth Engine through the code editor? Okay, it looks like about half of you. You can ingest an image into Earth Engine through Google Cloud Storage as well. So you can store your GeoTIFFs in Google Cloud, and using the command line, you can say, hey, Earth Engine, go get this GeoTIFF and ingest it into Earth Engine, not having to upload anything through the code editor. You can also create what we call COG-Backed image collections in Earth Engine. So the images can reside and stay in cloud storage, and they'll be registered in Earth Engine, and they will operate off those images in off of cloud storage, so you don't have to ingest them into Earth Engine. That workflow may be useful when you need to leave those images in cloud storage because they're part of some other process, or you're using them in some other framework or operation, and you can't just have them in Earth Engine alone. You can also read map tiles from cloud storage, and you can also read very simple blobs from cloud storage. I already talked about some of the data ingestion. If you go to the presentation, the agenda, there's links for all these docs, and you can get familiar with them. Okay, so here is a new one that we're all excited about. Who here has used BigQuery before? Okay, that's a good show of hands. So we have Earth Engine to handle massive amounts of raster data. Satellite images, derived products from satellite images, so on and so forth, gridded data. Within GCP, we have BigQuery to handle massive amounts of tabular data. And when I say massive amounts of tabular data, I mean massive amounts of tabular data on the scores of hundreds and hundreds of petabytes and trillions of queries at a time. One of the really neat things about Google BigQuery is it understands geography. There's a geospatial component to it. And so you can do geographic operations and functions in BigQuery. And so when we started thinking about how can we bring Earth Engine and BigQuery closer together, the first step was to be able to, let's start with exporting data out of Earth Engine into BigQuery directly. before, who here has done that before? Anyone done that before where you had to export it to cloud storage and ingest it into BigQuery? Okay, we got three or four hands. Before it was a little dance that you had to do that. Now you can do it directly. Okay, so here's an example. Let's say you have 1 million fields, agricultural fields, in Kansas, in the United States of America. These fields have been segmented, and you want to monitor these fields through time, okay? Let's say you want to calculate NDVI on a fixed schedule throughout the year, and you want to store that information in BigQuery so you can look at it later. This is exactly what we're going to do now. So here's a very simple demonstration that does this. You can see up here, we just have a little bit of information. I'll make this bigger so people can see. Some variables defining the year, a start day of year, an end day of year, a certain time step. We're going to do some cloud masking using the S2 cloudless product in Earth Engine. And we're going to go through and we're going to calculate NDVI for each one of these time periods. Now, if you were to hit down here at the bottom, it says export table to BigQuery. We're going to divide this up into each one of these time periods. And so for each one of these time periods, we could run this task. Now, I've already done this for you, so we don't have to sit here and wait for it to finish. But I can open up the Google Cloud console. If you go to console.cloud.google.com, you'll be directed to the Cloud Console. And I can click down here on BigQuery. Here in the project I have a data set called fields. I have a data set which are our field boundaries, which is the same thing that I was working in Earth Engine. This has the 1,072,000 rows. These are our fields that we wanted to gather this information on. If we just want to preview this data set, these are the different columns it has. This is the geometry or the geography column that shows the coordinates for those specific fields. And this is the information associated with each of those fields. This data actually came from the crop sequence boundaries produced by the USDA. But over here is we can look at our Kansas table, which had all that information that I exported. So this is a table that has 23 million rows. And if we want to preview it, it has a date associated with it. It has the field ID, and it has the NDVI value for that particular time period. And so you have these two tables, then you could just do a simple join and to be able to get that NDVI information for those specific field IDs. And so your mind might be, thinking about, I have a process where I want to monitor a polygon every 2 weeks, every month, every year, every 2 days, whatever it is. I can have this automated process. I can schedule this to be automated in Google Cloud, and I can export this data to BigQuery every single time, and then I can operate on it in BigQuery and send it downstream to my application. So that's exactly what we did here. If this is of interest to you, I believe it is tomorrow there is a session on getting data into and out of Earth Engine that's going to go in greater detail of exporting data out of BigQuery, or out of Earth Engine into BigQuery. Okay. I'm going to talk a little bit about Vertex AI now and what Vertex AI offers. Vertex AI is Google Cloud's umbrella solution for all things artificial intelligence. And within the context of Vertex AI, we have the ability to host models in Vertex AI and then to interact with those models in Earth Engine. So this is something that was highlighted in the plenary talk this morning. This is an example working with the National Agricultural Statistics Service, where they wanted to improve their cropland data layer that they produce for the United States of America. And so working with them, we have developed a simple process where we have developed a custom model that we will have hosted in Vertex AI. Earth Engine can then send information to that model, images in particular, pixels. That model can predict that information and send it back to Earth Engine, and we can store it as an asset or export it as an image or what have you within Earth Engine. So in this particular example, this is an example that uses a neural network, a custom neural network that was developed and then just hosted in Vertex AI. Over here, we just have the normal random forest operations that have been used for a long time in Earth Engine. And so you can see some of the differences there. I won't get into the details of this particular model, but if you're interested in that, please find me afterwards. And so the point here is with Vertex AI, you can have simple models, you can have complex models that you can host in Vertex AI. Earth Engine is not meant to be a complete modeling solution. It is an Earth observation platform. And it can do some things on the modeling side really well, but there's definitely some things it can't. And so for the situations where you can't do it in Earth Engine, Vertex AI is a fantastic solution where you can host your models and interact with them that way. Nick, raise your hand. Nick's teaching a lesson tomorrow, a session all on neural networks in Vertex AI. 2 sessions, actually. So please go to that if you'd like to learn more, or grab any of us and we can talk to you. Okay. So this is just an idea, an example of some of the services that we provide in Google Cloud and how they interact with Earth Engine. So we talked about serverless compute and in particular cloud functions and how you can interact and get information out of Earth Engine. I showed the example of building the endpoint. Hopefully that resonates with you and you can find an opportunity where you can put that into your workflow. We talked briefly about cloud storage of getting data into and out of Earth Engine. Highlighted BigQuery very briefly. We just launched this. We're really excited to see how people use this and how they can integrate it into their frameworks and their workflows. And then lastly, Vertex AI. So I'm going to switch gears a little bit now and talk about some of the management tools that we offer in regards to Earth Engine and Google Cloud. So in particular, identity access and management and cloud monitoring. So when it comes to Google Cloud, there is a hierarchy that has to be followed. And this hierarchy starts at the very beginning with an organization. Now, depending upon the organization you work for, or depending on if you are operating as an individual or as part of an organization, this may or may not be optional. But many organizations, be it private companies, public sector institutions, agencies, university, they have rules about how you can operate in Google Cloud. And so I encourage you to check with your organization first before you do anything. But everything starts at this organizational level. And then you can go down from there where you can have folders to manage your projects. That can be optional. But you come down here to what we call Google Cloud projects. And a Google Cloud project is required. That is where everything happens in Google Cloud. It happens in a cloud project. And then within a project, you have the resources that you use. And today we're going to be talking about Earth Engine, but Earth Engine lives within a project. BigQuery lives within a project. Cloud storage lives within a project. Everything lives within a project. So all cloud services need projects. And you can turn services on. You can turn them off within a project. Everything in Google Cloud is built on an API. So you can enable, and you can disable APIs within a project. So you can say, I only want Earth Engine to operate in this project, I don't want BigQuery or anything else to operate in this project. Or in this project over here, you can say, I want Earth Engine, I want BigQuery, I want Vertex AI, all turned on or enabled in this project. Also, within a project, you manage permissions and credentials. So you can say, Jane, I want you to have access to Earth Engine in this project. But for Mary, I don't want you to have access to Earth Engine in this project, but I want you to have access to cloud storage in this project. And then lastly, I apologize, I'm going backwards here. Lastly, you can track resource usage and quotas within a cloud project. Okay, so here's just an example where we have an organization. They have multiple projects. They might have one project for sandbox or development work with Earth Engine. They might have another project that's associated with monitoring or building land cover data products. And then they might have an operational or a production level project where they actually have their ecosystem watch type service that they provide. Within each of these, they might have different services that are enabled or disabled to accomplish the goals that they want to accomplish for that particular project. It's a really good idea when you start working in Google Cloud to think about how am I going to segment my projects, right? Because as I said, that's how you control things and that's how you monitor usage. If you want to know how much Earth Engine is being used for the land cover product, irrespective of what's going on with Ecosystem Watch, you need to separate those projects. And so it's a good idea to think about how am I going to segment my work? How am I going to segment my projects and separate them? Okay. Okay, I apologize. So this is a demo that you can actually follow along with. We can all create a project. We're all going to create a project within GCP and register it to use Earth Engine. So I'm just going to click on this link, and it's going to send us to a URL that you can't see. It's code.earthengine.google.com/register. And this is the easiest way to create a Google Cloud project and to register it for Earth Engine. And by registering it, we really mean two things. The first thing is we turn on the API, we enable the API, the Earth Engine API for that project, and then we register that project for non-commercial or commercial use of Earth Engine. So if you go to that URL, code.earthengine.google.com/register, you can click down here, register a non-commercial or commercial cloud project. It's the first thing it's going to ask you. I'll zoom out here. The first thing it's going to ask you is, how do you want to use Earth Engine? If you are a commercial user of Earth Engine or a government user that uses Earth Engine for operational use, you will select the paid usage of Earth Engine. If you are a non-commercial user, an academic using it for research or nonprofit using it for nonprofit activities, you can select the unpaid usage category there. We do ask that you be honest and please select the appropriate category for your use case. For this case, I'm going to select unpaid usage for training, as we are at Geo for Good. I'm going to click here. I'm going to say, click a training type project. I'm going to scroll down. Depending on your organization, you may or may not be able to do this, depending on the permissions that you have set. I'm going to say, create a new Google Cloud project. I don't have an organization. I am working on my individual account here. And I'm going to create a project ID. It's going to automatically populate it with a suggested name. I'm just going to add G for G23 after that. And I'm going to go to continue to summary. And it's going to confirm my cloud project information. So I'm going to hit confirm. And what this is going to do, this is going to create a new Google Cloud project. It's going to register it for Earth Engine and turn on those APIs. When it's done, it's going to redirect you to the Earth Engine code editor. And up here, you see that project is selected right here. And so all work that I do in the Earth Engine code editor at this point in time will be associated with that particular project that I just created. And so as you have different projects for different tasks and different workflows, you can switch between projects. You can click Change Cloud Project. You can hit Register a New Project. And you can switch between projects. That's going to be important because those projects are going to give you access to different data sets that live in those projects. They're also going to give you access to different services that have been enabled in those projects. If I click on Project Info, it's going to give me the information right here. If I click on Manage Project, it's going to take me to the Google Cloud Console. And this is, I should have changed the name for this one, but this is the Earth Engine default project. And it gives me the information about this project. OK, so we've created our project. Once we've created our project, we have to just define who's going to use our project and what are they going to use within that project. So identity access and management is all about who can do what on which resource. The resource we're most interested in right now is, of course, Earth Engine, right? And so that's what we're going to focus on. But that resource could be BigQuery. It can be cloud storage. It can be any other resource available in Google Cloud. So the who. So these IAM policies apply to 4 types of principles within Google Cloud. It can be in a Google account that has an email address associated with it. It can be a service account. Service accounts are accounts that are created within a project that are used for automated tasks. It can be a Google group, or it can be a cloud identity account, which is basically a service that syncs information from an external organization with your cloud projects. And so we start with these roles. Once we define who are we talking about, we want to decide what can they do. We want to define the roles that they have. So IAM predefined roles apply to a particular Google Cloud service in a project. So this is what can they do. So we're specifically going to talk about Earth Engine in this case. Earth Engine has some predefined roles that really make it easier to decide what people can do in a cloud project. And so we have the Earth Engine Resource Viewer role, which really just gives you the basic level of Earth Engine access. It's just the most basic, the ability to view and list assets within a project. Most of the time, the most pertinent roles are going to be the Earth Engine Resource Writer role or the Earth Engine Admin role. And so those 2 roles allow you to do everything within Earth Engine within that project. In addition, we have a 4th defined role, the Earth Engine Apps Publisher role, which allows you to publish Earth Engine applications within that project. So once you define the specific role, what we're talking about, what they can do, then you apply that role to that specific service. So I'm going to walk through a quick little short demo here to do that. So I'm going to go back to this new, see where it is. I'm going to go back to this new project that I just created. I'm going to go over here to Identity Access and Management, IAM, right here. And this is going to list for me all of the individuals that have access to this project. And right now, this is just using my individual account. It's just showing my account. I am the owner. As owner, I have access to absolutely everything in that project. I can do whatever I want in that project. But let's say I want to grant access to a specific individual or groups of individuals or a service account. What I can do is I can hit Grant Access, and I can type that individual's email address or that Google account's email address. I'm going to just do my Google email here. I can type that in there, and then I can assign them the specific role for this project. And I'm going to give them the Earth Engine Resource Writer role. And I hit save. And now my Google account has access to this project and can run all the Earth Engine operations it's need, and they will be tracked. The resource usage will be tracked in this project. It will use the Earth Engine quota available to this project, and they will also have access to the Earth Engine assets within this project. These roles are predefined, and they actually combine a whole bunch of cloud permissions for you. And so if you go down to here on roles on the left-hand side of the screen, you can click on that. And here you can type in Earth Engine. And these are the predefined roles that are available in Earth Engine. And so for the Earth Engine Resource Writer, you can click on it, and it gives you all of the default permissions associated with that role. And as you can see, most of them, I'll make this bigger, most of them are associated with Earth Engine in particular. These permissions allow you to do certain things, certain operations within Earth Engine. Okay. So this becomes really important because as you start building these frameworks and pipelines in GCP, you have to make sure that individuals or service accounts that are doing automated work on your behalf have the correct permissions in order to do the work that needs to get done. Also, you also want to make sure that they don't have too much permission. You know, for example, if I'm working with Joe on my team and I just want Joe to be able to access Earth Engine but not be able to access BigQuery, I need to be able to set that explicitly. And so it controls who can do what on which resource. Okay, we're going to go back here. Let's see. Before I leave on identity access and management, I want to show one more thing. So when you're working in this project, and we have this project selected here, this new project that we created, you can click on Assets, and this is our new project. Assets also live within a Google Cloud project. This folder is empty. This is a brand new project that we created, and so there are no assets in there. If I were to create an asset, if I were to export an image, it would live within I could export it to this project, and it would show up and live within that project, show up on the screen. You can, if you want to share assets with individuals, you can also share them at the project level. And when you do that, you give individuals access to all the assets within your project. And so I can click this button right here, share the project, and it will open. This is just a quicker way to get to the same screen I was showing earlier. It will open the IAM page on the Google Cloud Console, and you can add individuals that way. Okay, the last thing we're going to talk about is monitoring. So within Google Cloud, there is the cloud monitoring, which allows you to monitor resources consumed. And within Earth Engine, we have two metrics that you can monitor. The first is a measure of storage, the amount of bytes for particular assets in a project. And the second, and the one that we're going to demonstrate today, is what we call Earth Engine Compute Units, or EECUs. Now, EECUs are an abstraction or a measure of the amount of computation that goes into an Earth Engine operation. And so with cloud monitoring, you can monitor your Earth Engine, your EECUs in real time. So here we have a graph that shows for a few hours, I believe I made this last week, that shows the amount of EECUs over a time period of 2 or 3 hours for online compute. And here is a graph that shows the same thing, but for batch compute. And so online compute is when you're interacting with the online stack. Batch compute is when you have a batch job or an export job, and you're interacting with the batch stack. So I'm going to show you, we're going to walk through a live demo here and show you on the fly how this works. Because I get asked a lot of questions of how do I monitor, how do I measure how much Earth Engine compute units I used for this particular operation. So I'm going to click on this link, and it's going to open up a simple, zoom out here. It's going to open up just a simple script that calculates NDVI using Sentinel-2 data. Nothing special. It does a little bit of cloud masking as well. We'll give it a second to get going here. This is just to generate some activity into our account so we can go in and look exactly how much Earth Engine compute units were consumed. So there we have NDVI for the state of California. I'm just going to zoom into this area here. I am not familiar with California, so I don't know where we're at, but we're going to let this fill in here and calculate NDVI to get some activity going in our account. So we'll let that finish real quick. I imagine everyone's on Earth Engine right now, and so it might take a few moments. Here we go. Give it a few more seconds here just so we have enough activity. Okay. So I'm going to go back to the Google Cloud Console. I'm going to zoom out just a little bit. If you have trouble seeing that, let me know. And I'm going to click on monitoring, and there's a section here called the Metrics Explorer. So we're going to open that up. I have my Earth Engine default project was the name that was provided for this project. We have that project selected. I can go in here and I can type in Earth Engine. And it has one metric available to us. Used EECUs. And so I'm going to click on this, and I'm going to hit apply. And it's going to give us a graph of the amount of EECUs that was used in this most recent operation. But I'm going to warn you right now is there's a few things we need to do in order to make this information useful. And so you come down here. Let's just zoom out again. You come down here. We're going to group this information by compute type, whether it's online or batch. I'm going to click OK. And then the most important thing is down here, our alignment function. We're actually going to use a sum function, which is basically going to sum up the amount of EECUs for the particular time period that we're looking at. And we're going to have it set on a 1-minute alignment. You can change that to whatever, however you would like to aggregate that information. And so what we're looking at here, and just for demonstration purposes, I'm going to select the stacked bar chart because it makes it easier. What we're looking at here is a graph of the amount of EECUs used in the most recent operation that I just did. So this measures the amount of EECUs used from 12:45 p.m., this is on Mountain Time, to 12:50, so for the last 5 minutes. And here we see that it's used 18.47 minutes of EECUs. EECUs are measured in seconds. That is the base unit for EECUs. Cloud monitoring will convert that to a more readable format. And so it's converted that to minutes in this case. And so if I were to go back and move around some more, pan around on the map, calculate NDVI in some other areas, it will show up on this graph and it will be updated in real time. Since this is a new project, I don't have any batch information for you. But I'm going to select a different project here that I do have some batch information. I'm going to change for the last 2 weeks or 7 days, I will say. And I have to go back and change my metrics again, or put in my metrics. EECUs. Group it by the compute type again, and change the alignment to sum. And I'm going to change it to a bar chart because it's easier to understand. And so I changed my time period to 1 week. And here I have the amount of EECUs for a certain batch task, which used 1.146 weeks of EECUs. You can convert that to seconds or convert it to any other time unit that's more applicable here. And so many times, this gives you a sense of how much computation did this particular operation take? How much Earth Engine did I use, essentially, to calculate that NDVI mosaic, to calculate that land cover map or what have you. The neat thing is I can go up here and I can click Save Chart, and I can give it a title. We'll just leave it at that, used EECU sum, and I can create a dashboard, EE dashboard. I have to create a new dashboard. We'll call it EE dashboard. And I can save this chart. And then if I want, I can view this dashboard as part of cloud monitoring. And this dashboard, it's set on the same time period that we set it with. This dashboard will automatically update as more operations occur in the future. And so people always ask us, well, how much computation did I actually use in this operation? So this is a really good way to get at that information, both in real time for online compute, and then for batch compute, once the task is completed, it will show up here as well. OK. We're going to go back. All right. So that's all I have. Hopefully, I realized that was essentially a brain dump here on the table of a lot of information of how Earth Engine interacts with Google Cloud Platform. We're happy to take questions now if you'd like to ask questions as a group, or we can follow up throughout the day and the week.
Yes, thank you for this excellent presentation because it answered many of the questions that we had before we came here. I was wondering if this information is also accessible for legacy projects.
I'm sorry, I didn't hear that. For what?
Is the information that you just showed in the chart on the EECUs also available for legacy projects or only for cloud projects?
It's only available for cloud projects.
OK.
Yes.
For the computing, when you share the project, is that going to be compute through your account or the shareable, like the other end?
So I think the question, and correct me if I'm wrong, I think the correct question is when you share a project or when you share work with an individual, where does the computation get tracked essentially? To which project does it get accounted for?
Correct.
So here, if you're working in the code editor, it goes to the project to whichever Earth Engine has been initialized. And in the code editor, you can select the project. So if an individual has access to your project and they select that project, the usage will be attributed to that particular project. So that's for the code editor. If you work with the Python client library, you can initialize the Earth Engine project, the Earth Engine library, and specify the project during that initialization step. Thank you.
On the charts that you were just showing, is there any way of having an automated report saved or generated?
Yeah, fantastic question, which allows me to mention something I failed to mention. The information in cloud monitoring is only available for 6 weeks. And so the information only stays there for 6 weeks. If you want to retain that information longer, you need to get it out of cloud monitoring. And so cloud monitoring also has an API that you can interact with, and you can export that information. And most commonly, people do it, they export it directly to BigQuery. Is it automated? I don't believe so. I think you have to set it up yourself.
Yeah, only if you have billing enabled, you can automatically log the billing, which will take similar data but apply dollars to it, and that will automatically be logged to BigQuery. You don't have to do anything. If you want to log cloud monitoring, we do have a blog post about setting up a cloud function to automate that. But there's a couple steps involved for you to do it. But if it is build, you'll get that. You can just click a button and provide a BigQuery table, and it'll log all the usage with the EECUs and the dollars that you spent, like any other cloud billing.
And cloud billing keeps data for a very long time. The other thing I failed to mention is if you go to our developer site and the documentation about API monitoring, you can set workload tags. And so you can tag specific operations within your Earth Engine workflow. You can give them a tag, and that information will show up in cloud monitoring as well. And so if there's a specific land cover operation, for example, you can say, I want to track the amount of computation used for this land cover operation. And so you can parse things out appropriately. Okay, we have 5 minutes left, and so we'll take one more question.
You just answered my question.
Okay, so I can take another question. Any other questions? We'll start up here in the front. Oh, it's going to the back. It's going back to whoever had their hand up in the back.
All right. So what are the best practices for setting up, like how many projects do you set up for, because maybe you're developing an algorithm, you're deploying it, you have multiple users experimenting in it. Do you set up lots of projects so it's really easy to do the monitoring, or you set up a single one because it's easier to give quota to a single project?
It really depends on your workflow and how you want to set things up. I mean, the recommended best practices are to set up projects and to segment them appropriately by some activity level, right? And so you can track, because development and prototyping is going to be different than production. And so if you want to be able to track usage and to monitor that, set that up. My personal opinion, it comes down to whether you're a lumper or a splitter. And so you just kind of have to figure out what works for your use case. But I always recommend, segment to a certain degree. And yes, you're going to have to change quota for different projects and such in order to get the results you need. But that usually pays dividends in the long run. We have one last question. Oh yeah, Matt, go ahead. Throw me a softball.
So yeah, no, it's actually not. You mentioned registering a COG in Earth Engine. Is there something different there between reading a COG like ee.load.dochif and having it as an asset? Is there something different now that you said register?
So you can register image collections in Earth Engine that will essentially look to a number of COGs within cloud storage and act as an image collection in Earth Engine.
Individual TIFFs anymore. You can read.
Exactly. So the read from, and I'm blanking on the function name, but the load from GeoTIFF or whatever is for individual images. But you can create a COG-Backed image collection that does the same thing with multiple COGs in an image to create an image collection.
Okay, great. Thanks.
Okay, no one's getting up and leaving yet, so there was one last question in the back, and we'll take it, and that'll be the last one. And while he's walking back there, again, thanks, and I'm around, we're all around, so please feel free to grab us.
Hey, ooh, that was loud. Hey, Brady, thank you for the presentation. I wanted to add like a comment and then maybe like a clarification. Maybe you can clarify with us. So at SIG, we've kind of started to line all the cloud monitoring up. We've set up one cloud project that has all of our other cloud projects in metric scope, in monitoring scope. And just curious if you could like comment on that. Is that a good practice? Yes or no? When? Where?
And so they're within monitoring scope, so they can read the metrics from the other projects?
Yes. So then we have like custom dashboards so that we can just look at all of our EECU usage from one cloud project, and then like do like alert policies and stuff like that.
Yeah.
So
that's perfectly acceptable, and if that streamlines the process for you,
yeah,
that's fine. As long as downstream that the actual work is being done, as long as it's getting attributed to the correct project, that should be fine.
Yeah, exactly. Okay, thank you.
Thank you, everyone.
it.